going to discuss the question from signals and systems given in GATE 2000 from the LTI systems. So a linear time invariant system has an impulse response e power 2t for t greater than 0 if the initial conditions are 0 and the input is e power 3t, then the output for t greater than 0 is. So here given that a linear time invariant system with impulse response and with input with initial conditions taken as 0, then we need to find the output of the system. Come into the solution. Given a linear time invariant system, with impulse response is, let us consider h of t with input x of t, then we need to find the output y of t here. Then we know that for this always the output is nothing but that is the convolution between x of t and h of t. So like this we can find the convolution here. So then we will get the y of t. So here given that x of t equals to e power 3t u of t and h of t equals to e power 2t u of t. So by giving like this we can find the output using Laplace transform, that is by applying the Laplace transform here we will get y of s equals to, using the Laplace transform property, the convolution property of the Laplace transform, this becomes x of s into h of s. After finding this we will go for taking the inverse Laplace transform to get y of t. Then that is one procedure. Otherwise we can simply find by using the simple expression, that is always the convolution between e power minus bt u of t convoluted with e power minus at u of t is always equals to 1 by b minus a of e power, always this is equals to e power minus bt minus e power minus at. Even it is e power minus or plus, this is the expression. So here given that minus b equals to 3 and minus a equals to 2, then it becomes here we can observe that even it is plus or minus, no problem. If it is plus, then it becomes e power b plus bt and this is e power minus e power plus at. Then b equals to 3 is given and a equals to 2 is given, then this is 3 minus 2, this is e power 3t minus e power 2t. Simply we can find the answer, that is e power 3t minus e power 3t minus e power 2t is the answer. Directly we can find like this. Otherwise you will go for this process, that is finding the Laplace transform and applying the inverse Laplace transform, that we will see here. So given that y of s equals to x of s into h of s, so before going to that we need to find the x of s, that is nothing but Laplace transform of x of t here, that is Laplace transform of e power 3t here, Laplace transform of e power 3t into u of t, that is equals to 1 by s minus 3, that we know, and the Laplace transform of h of impulse response, that is h of t, equals to, that is the Laplace transform of e power 2t u of t, that is equals to 1 by s minus 2. So by substituting here we'll get y of s equals to 1 by s minus 2 into 1 by s minus 3. So by applying now we need to find the y of t by using the partial fraction method. So we can write this as a by s minus 2 plus b by s minus 3. Now find the a and b values. So finding the a and b values, we'll get a equals to minus 1, that is minus 1 by s minus 2, plus b equals to 1, we'll get 1 by s minus 3. So by applying the inverse Laplace transform, then we'll get y of t equals to, this is minus e power 2t u of t plus e power 3t u of t, then it is equals to e power 3t minus e power 2t into u of t, that we can write it as e power 3t minus e power 2t for t greater than 0. That is the answer that we got. That same we got from the expression e power 3t minus e power 2t. That is the answer A here, option A here.